Hi folks, this is College Algebra Quiz 9. We're asked to write the augmented matrix associated with this system of linear equations. So remember what that means is for each equation we're going to have a row, and we're going to have a column for the coefficients of each of the variables, and then we're going to have a vertical bar, and then we're going to have the constants. So our first row comes from the first equation. I have 3x minus 2y plus 1z equals 5. The next row I have 1x plus 2y minus 1z equals 2. And the last equation I have 1x 0y minus 3z equals 7. And that'll do it for number 1. Number 2 then is the opposite. I've given you a augmented matrix. I want to know what system corresponds to that. So we can use x, y, and z as we did in class, or x1, x2, x3. I don't really care. But it's 1x. I'm going to use x, y, and z. So I have 1x plus 2y minus 1z equals 3. I have 4x plus 7y minus z equals 5. 2x minus 3y plus z equals 0. And then that'll do it for number 2. Number 3, classify the system represented by the matrix as consistent independent, consistent dependent, or inconsistent. Explain your answer. So let's take this thing out of the matrix using x, y's, and z's again and see what we get out. We get x plus 2y minus z equals 3. I have no x, y plus 3z is 5. And then I get 0 equals 0. This is going to be consistent dependent. We're going to get infinitely many answers, and the reason is this. This equation here, z is a free variable. In other words, we're going to let z be any real number we want. We can use y and x to solve in terms of z, but you're going to have infinitely many solutions because we have a 0 equals 0. In other words, there's no equation that's going to pin down exactly what the z is. So that means it's consistent dependent. Alright, number 4, same thing. Let's go ahead and bring it out of the matrix using the variables x, y, and z. I have x plus 2y minus z is 3. Y plus 3z is 5. And then I have 1z equals 0. So this one tells me that z is 0. Once I know z is 0, I can plug it in here to get y, plug it in there to get x. So I'm going to get one solution to this system, which means it's consistent independent. There's only one solution to the system. And now contrast this with number 5. Number 5, the bottom row has all zeros and a 1, but where the 1 is makes all the difference. So once again, if I decode this x, y, z, I get x plus 2y minus z is 3, y plus 3z is 5, and 0 equals 1. Well, this is inconsistent. There's no solution, because we have a false statement. 0 is never equal to 1. And then that'll do it for quiz 9.